All right. So let's think about keyboard inputs. So what I'm thinking is we'll add uh, a few things here. We'll have a key code um, a key code file that's kind of just exports our types for uh, for our system. So we'll have in our core, we'll put a input folder, and we'll have a keycode.ts. Oops. Keycode.ts. And instead of typing all this, we'll just paste this in here. I'll try to get the GitHub up before the end of this video. So what this is going to do is it's just going to help generate all of the key codes for type safety. That way we can utilize them in our project here. Okay. And then I think we'll want to create a controller component. Yeah, let's work on that. All right. So we'll create a new file called input.ts. We're going to import key code and is key code from that file we just created. We'll export class input manager. It's going to have a private set called down. New set. This will be set key code. We'll have a pressed, a released, and we'll have a prevent. Is a set of key codes. And we can start this off with key code dot arrow. We'll start with up, arrow down, left, right, space, and tab. We'll have our constructor. Once we will set on key down. Let's see. We'll create these functions in a moment. And we'll listen to the events. Let's create these. These will be private. On key down. If is key code, we return. If this dot prevent dot has key code, then we will prevent default, of course. We'll say if this dot down dot has e dot key code or e dot code, this dot pressed dot add e dot code, like so, and this dot down dot add. Private on key up, keyboard event. If this is going to be a lot of the same. If step down that has edat code, and then step down that delete. Private on blur. This dot reset will create the reset function. This will be a public reset. This dot down dot clear, this dot pressed, and this dot release dot clear. We'll create some other helpers. So public set prevent default keys iterable code. This dot prevent new set keys. And then we'll have some more methods. So one could be is down. Turn this dot down dot has key. Was pressed. That will take a key code as well. And was released. And then we need these to be public. You don't have to specify public, by the way. I just like doing that. It makes it clearer. Public and tick. and this will return void. And at the end of each tick, we will clear our pressed and clear our released. All right. And then we need to close this. And then we'll give access to a value, which will just be an instance of our keyboard manager. So this is where we'll create our instance to use. All right, let's kind of walk through this. So we're getting that big generated key code file. That's so that we have all this. We have all these available to us, right? So that we have a lot of type safety and autocompletes. So we've created a class, and it's going to have multiple sets, which will contain the keys that are in their different states. These sets will only include the keys that are in its respective state. Prevent is going to have a list of keys that when pressed, we try to ignore what the default browser responses are, such as, let's say you hit the tab key and we want to bring up our custom menu. Well, we don't want it to tab focus to a different element, so we prevent that from happening. So we bind our functions so that we can, so that when we call them in our listeners, really we could pass, we could just create a anonymous function here and call the function with the event data passed through it. But this right here is just a little bit quicker, more evident implementation. Tells you what we're doing. Reset. Whenever reset's called, we clear our sets. Is down will check the state of a specific key if it is within the down set. Same thing with the was pressed, was released. Set prevent default is a way to override the defaults and potentially add new ones. We could probably add public get prevent defaults, and that will give us the ability to access it. If we want to build upon it, we'll be able to do that. So end tick is what we'll call at the end of our update for, let's say, our control system. And that will clear out the pressed and released so that the next time through, it has to be true again. Let's see, on key down, this is simple. We're just going to check if we need to prevent the default action from happening. Then we check if the key that was pressed is in the down state. If it isn't, we add it to it. We add it to pressed and we add it to down. That just means the next go around, if it's already down, then we're not going to consider it pressed. So at the end, we clear it and it becomes not pressed. It's only pressed for an instant. On key up is similar. And on blur. All right, sorry about that. All right. And then we can call the we'll call the on blur. Obviously, we bound these ones. These get called when these events are fired. All right, so the next logical thing is to create a component. Let's see, we'll go into the ECS components. Let's create a new controller. And just like every other one, it's fairly easy now to create a new component. Export the controller. That's equal to define component and what our properties are going to be. We'll have left and let's see. This will be an array of key codes. Actually, we're defining this object here, so I think it's. Oh, that's why we are passing in an object. And this way, these will all be considered key code types, and they're arrays. And then we'll export type controller is equal to return type of controller. Create like we did for all of our other ones. And let's see. Did I put that? Let's get this from at all right. So we'll have a few other controllers. We're going to split some things up, I think, as well, so that we can kind of revamp a bit. Okay. So we're going to have another component. We'll call this one DesiredMove. Import. One sec. All right. We're going to import, define component. And then we'll export desired move, find component. EX simple enough. We'll have another component called Locomotion. Locomotion. And ready. So this one, we're going to do the same stuff. Why are we putting stupid stuff in there? Define component, export const, locomotion, define component. We'll have a max speed. Let's put some defaults in here. 200 as number. Accel. And let's put 1400. Number. So this is pixels per second squared when moving forward desired. Decel. And let's add 1800 as number. Pixels per second squared. This right here is also pixels per second. There. And then we'll have a drag as well. This is our seconds over -1. Gentle, it's a gentle bleed. 0 is equal to none. 1 is equal to stop in 1 second. And we do the same old export locomotion. Okay. So now we can start acting on these systems. We'll create a new keyboard control system. We're going to import type system from system, import type world, import our controller, import DesiredMove, import type key code, and we'll import the input. We're going to add a function that we can use called anyDown. This will take an array of keys, read only code, and it's a fairly simple function. We just k of keys if input dot is down k return true, else we return false. There we go. So we can create this keyboard controller. Keyboard control system is a system, and it will have an update world, will be world, and we won't take in update. Oh, we don't need delta time. C is equal to controller.get. No, we need first. We're going to get const e of world.query controller and desired move. Then C is equal to controller.get e, and const D is equal to desired move. So we'll let x equal 0 and y equal 0 to start. If any down, c dot right equals 1. If x is not equal to 0, or y is not equal to 0, const m math dot. We have a handy hot, which I think this returns the square root of these two. And then x divided equals m, and y divided equals m. D dot dx is equal to x, and d dot dy is equal to y. And then we end the tick for our input. Clear one shot flags once per sim tick. So this is the entire system here. We're going to get entities that have both a controller and a desired move. Then we're going to create a initialized x and y. We will increase the x or decrease the x by 1, depending if the key is down. And then if they aren't equal to 0, we get the distance, which essentially is like the direction, essentially, that the vector is facing for their desired movement. Okay. All right, from here we'll have another system. This will be the steering system. This one will import type system. We'll import our world. Import the desired move. Import our locomotion. We'll export const steering system, which is be a system. And it will have our world, and the, oh my god, why does it do this? There we go. EPS. All right, so, all right. So EPS will be equal to 0.001. And this is treat very small numbers as 0 to avoid jitter. That's just a number. If it's less than that, then we will essentially stop it. It is not moving. That makes sense to me, right? I hope it makes sense to you. So let's get our entities like we normally do. Const e of world.query desired move and locomotion. And we need one more. We probably are going to want the velocity. All right, so let's say where we wish to move is equal to the desired move. Loco, the locomotion, and velocity. Makes sense? I think so. We're going to target velocity from desired direction. TX, our target, is where we wish to go. Y is equal to wish. There we go. And we'll get the delta toward our target. dvx is equal to tx minus the vel.x, vx, vel.vx. Const dvy 3 will choose Accel versus decel based on whether we're moving toward target. So const will get the dot product of dvx times vel.vx plus dvy times vel.vy. That is our standard dot product. Rate is the dot product. If it's greater than 0, then we are going to Accel or decel. Four, we're going to apply a bounded change toward target on this tick. Const math delta math dot hypotenuse dvx and dvy, which gets us the I guess it is the change there. If mag delta is greater than our epsilon value, which is basically as long as it's greater than that tiny little number, that will start, we'll consider it 0 if it's less than that. K is equal to, const S is equal to math dot minimum of 1 for max speed divided by mag delta. And it's const max step. I forgot this here. I put it, oh man, that goes right there, right there. That makes sense. This should be max step. And then, there we go. Step 5, optional drag. So this is where we will put that. Right. All right, sorry, I keep getting interrupted. So we'll set the drag. So if loco.drag greater than 0, const k is math.max of 0, 1 minus loco.drag times the delta time vel.vx times equals k, same thing with vy. And 6 is just clamp the max speed. Const speed is equal to math dot hypot vel.vx and vel.vy. So if speed is greater than loco dot max speed, S is equal to loco dot max speed divided by speed, and that's that. lastly, 7 dead zone to prevent micro drift. That's what we'll do if the absolute speed of either is less than the epsilon value. They are considered 0. I think that that should be all it takes for us to incorporate that. So we can import our keyboard control system. We can import our movement. We already have movement. Desired move controller and locomotion. And then we have what system? Steering system. And let's move this down to systems. And that's easy enough to add our systems to the update. And now we can create velocity. We can set these 0 and we no longer be movie. World.add controller e controller.create Look at this. We are moving. We are moving. Who's moving? We're moving. WASD. That was some work, but we got it working. Okay. This is going to be cool. So one thing you'll notice is we have these these big long lists of stuff, right? Of things that we're adding, right? So we can also do something like create prefabs, which prefabs are just like you create a player and you spawn a player, and you'll have some player defaults or entity defaults for like enemies or things like that, and you can create derivative prefabs. And that way, you build up these components in a single spawn. So you will see that when spawning or creating a entity of a certain type, we don't have to repeatedly add all these components for every new entity, thing like that. And one thing cool about this system too is right now we're doing we're doing keyboard, but because we're using directions, we should easily be able to add mouse movement, maybe AI pathfinding, things like that. So yeah, that seems like we're moving in a good direction. One thing I also think would be cool is an event system so that you could do things like replay, create replays or any of those kind of things. Reverse time, let's say we're making a game with single player mode and one of the mechanics is to reverse time. You can do that and reverse your actions. You can record your actions. Also, that'll be great when it comes to potential multiplayer down the road. If you have an event system, you dispatch your events, those have timestamps, and you can do a lot with that. I think this is cool. I know it was kind of a funky stop and go today, but this is looking good. We're getting a lot of core systems in place, and once we start on a game, we might modify or change some of these, move these into a game specific or create game specific components and systems. So yeah, this is coming along. Let's maybe I don't know, maybe we'll work on getting a tile, some sort of tiling down, something like that. We could probably work on like an event system later on. But for now, I think that's pretty cool. We are moving our square. How awesome, right? Yeah, I think that's fine. Cool. I will see you guys in the next video.